Okay, given f of x equals x squared minus 4, graph y equals f of x and y equals the absolute value of f of x on the same grid below. So what I'm going to do is I'm just going to make a table of values for basically both of these graphs, for y equals f of x and y equals the absolute value of f of x. So it's just going to be one big table of values. So I've already set up my x values. I'm going to use all integers from -5 to +5, and I'm going to sub them into each function. So y equals absolute value of f of x, it's worth noting, is really just the y equals the absolute value of x squared minus 4. Now I'm just going to sub all those x values into f of x and then into absolute value of f of x. So first, subbing -5 in, -5 squared is 25, minus 4 is 21, -4 squared is 16, minus 4 is 12, and I just keep on going down the list like this. Next, I'm going to start subbing into the absolute value. So I'm going to put -5 in first. So -5 squared is 25, minus 4 is 21, but then at the end I have to take the absolute value. So the absolute value of 21 is 21. -4 squared is 16, minus 4 is 12. Absolute value of 12 is 12. -3 squared is 9, minus 4 is 5. -2 squared is 4, minus 4 is 0. Absolute value of 0 is 0. -1 squared is 1, minus 4 is -3. Now I'm taking the absolute value of -3, and I get +3. 0 squared is 0, minus 4 is -4. Absolute value of -4 is +4. 1 squared is 1, minus 4 is -3. Absolute value of -3 is +3. 2 squared is 4, minus 4 is 0. Absolute value of 0 is 0. Etc., etc. We can finish this list off quickly. What I notice though now, just looking at the values, is the numbers that I actually took the absolute value of isn't the x values. You never take absolute value of x values. It's always the y values. So in that little area between x equals -1 and +1, those three values for f of x are -3, -4, -3. Those are where the absolute value makes those numbers positive. They become 3, 4, 3. So it's really important to notice that. And then you go, well, how do you make a negative number positive? You times it by -1. So f of x times -1, or in that little bit, it becomes negative f of x. So summarizing this, the important thing is that positive y values or y values that equal 0 stay the same. Negative y values become positive. X values never change. Okay, now we just have to graph this. So first thing I'm going to do is I'm going to plot all my points for f of x. So there's the point -4, 12. I'm not going to use -5, 21 because 21 is way too big for my graph. So there are my points for f of x, and I'm just going to connect them, and I get a parabola. And now I'm going to start graphing the absolute value of f of x, and I'm just going to be graphing it right on top. For many of the points, it's right on top of f of x, but in between -2 and +2, where x equals -2 and +2, it actually reflects up above. So that's interesting to see, and it's important to notice that between -2 and +2, so -2 and +2 are the x-intercepts. Between those 2 points, it's like little regions. If we go to the left of -2, which is what this is arrows showing right here. If you go to the left of -2, f of x stays the same. So f of x, the graph, is above the x-axis, so it stays the same. To the right of +2, f of x also stays the same. But in between -2 and +2, where the graph of f of x is below the x-axis, that's where it gets reflected up above, which is the same as multiplying the function by -1. So basically, in that region between -2 and +2, we're reflecting it in the x-axis, which is the same as multiplying by -1. So anywhere f of x is less than 0, we're reflecting f of x in the x-axis, which is the same as multiplying by -1. So it's like to the left of -2, it's just f of x. To the right of +2, it's still just f of x. But between -2 and +2, it's negative f of x.